Sweet, we're live. Okay. Does anybody have any questions from the individual prep assignment?
Nope.
I do not. I know. Sit down from the shock, but Kaylin doesn't have a question.
And Veronica, did you have any or no?
I think I didn't. I think I'm okay.
Don't feel bad if you have any and none of the rest of us do, because we
right, and exactly. The first time around, I was like, "What?" But then I calmed down and I did it again, and it was okay.
Yeah, no, I think I remember this one pretty okay. I'll let you know if I have any questions.
Cool.
Okay.
How many people got sucked into the did the whole formula before they realized it wasn't a normal distribution and you couldn't use the applet?
I did that a couple times last semester.
I was like, oh, psych. But anyway, I just thought that was funny.
All right. Then I guess, are we ready to get started on the group assignment?
Yes.
Yeah. Cool. Who wants to start us off this week?
I think Hay should.
Oh, okay.
Sorry, Veronica. I was just like teasing Hay because she's been gone, so I was picking on her.
Fine.
You gotta make up for time lost, right?
That's right.
Okay, I'll start then. So number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equal 1.358 and to the left of z equal negative 1.358. I got 0.175.
That's what I got.
Yeah,
I have the same thing.
Yay! Who wants to do 4? Because I started reading it. I'm like, I'm out. I'm just waiting for the group. I was like super confused. It was like too much. It was boggling my mind. So.
Okay, so I'll walk you through it
okay.
as I read it.
Good. Do it.
So, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. So that's going to be mu.
Right.
So mu equals 185.
Right.
Yes.
The previous value was lower, but raised after a tragic boating accident. The standard deviation of the passengers' weights is 26.7 pounds. So the standard sigma is going to be 26.7.
Right.
The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of the passengers will have a weight that is as extreme or more extreme, so either above or below the mean, than was observed in this sample.
So are they saying above or below the sample mean?
Mm-hmm. So you'll find the z-score for the 177.6 pounds, and then you find the right and left sides.
And so, it's not the complicated one where you have to do the square root because it's a sample of the mean?
It is that one.
Okay.
Because when you do, wait, hold on, maybe it's not.
So is it 176 minus 185 divided by 26.7 and the square root of 45? Or 48, I mean? Is that the z-score, or is it just a normal one?
I think it's just a normal one. Let me go. I'm going to go back to the book to clarify that.
So then the normal one would be 176 minus 185 divided by just the deviation, right?
Yeah.
Okay, so let's see what that would be. Because I wasn't sure from what they were saying which one you did. Because they talked about 45, so that is a sample, right?
But the question is asking, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. It's not asking for the probability of the random sample of 48. Does that make sense?
So the mean would be the 177.6?
That's the mean for them, yeah.
Okay.
Wait, now I'm confused
So
here.
then the value would be 48 passengers, right?
I don't think we need to use that 48.
Wait. Okay. The mean of the population is 185. And then the sample mean, see, that's why I think it has to be that more complicated formula. Because they're giving you the mean and the sample mean, and it's like, find the probability that a random, I'm confused. I don't know. So it's either one or the other, but I don't know which one.
So
Yeah.
in the textbook, it'll say, suppose the sample size has been drawn from the normal population and it has this mean. Yeah, I'm trying to find. For the mean of draws from a random variable with mean mu and standard deviation, the following are true.
The sample. The mean. The sample mean was determined to be. So wouldn't we use the z equals, I don't know, the x with the little line, I don't know what that's called, minus mu divided by the standard deviation that's divided by the square root of the. Wouldn't you use that one? Because if you look on the textbook and you go down to.
I'm thinking that as well. So
You go down to number 3. Well, it says right there 3 probabilities involving a mean. If you go down a little more after you see the applet, there's a question somewhat like it.
That have a weight that is as extreme or more extreme. That was okay. So I think it is
the other one.
You use the sample one. Sample means, and then what you're saying is you're finding out.
Wait a minute. No, there's something not right.
What goes above or below that 176-pound z-score.
Oh, I know what we're doing. What we're looking at. The equation for the distributions, the standard deviation of the distribution of sample means is that sigma divided by the n, right? And I think that they give to us, right? Don't they give that to us? The standard deviation of the passenger, the weight is 26.7.
Yeah.
Well, that's the one of the main population, and then they give us a sample mean. So I think it's that 176 minus 185, which is the population mean, divided by the standard deviation divided by the square root of 48, which is the total the total of people that were sampled.
Hey, what are your thoughts on this? I haven't heard you say anything.
I don't know. I'm trying to solve it right now, like do it, but.
The sample mean. Okay. Yeah, I think that's what it is. I think you're right. The sample mean would be 177.6. We subtract that from the mean of the weight mean of 185.
Right.
And
which gives us negative 7.4, right?
Uh-huh.
And then the deviation is 26.7 divided by the square root of 48, which is 6.928. Check my math. Is that right?
Okay, hold on. Let me do it again. Sorry.
Square root of 48 equals 6.928.
Yeah.
And so then you divide 26.7 divided by 6.928, 3.928, which equals 3.854 if you go to the third decimal. So it's negative 7.4 divided by 3.854.
What?
I'm confused.
Say that
Okay.
again?
Okay, so the formula is, right, the random mean, the sample mean minus the population mean divided by the standard deviation, which divided by the square root of the sample, right?
Okay.
Yeah.
So the top number is negative 7.4. The bottom number is 3.854. So you divide negative 7.4 by 3.854, and you get a z number of negative 1.920. That's what I got, but check my math and see what you
I
think.
got the
of that
same thing
formula.
with your math.
Okay, good. So then, but what's confusing is then we go to the applet, and then we plug in that z-score, right?
What was that z-score again?
Negative 1.920. So then what they're asking is find the probability that will have a weight that is as extreme or more extreme above or below the mean than was observed in the sample.
So then you highlight the middle
I thought
and
I thought
everything to the right of the negative.
I think
No,
it says
you
either
want
above
sides.
or below the mean.
I
You want to do each side.
Okay, hold
I
on.
think you take the left and the right side, correct?
Well,
Yeah.
And you add those together, those probabilities together, which is zero. I mean, if you click both of them, it will give you 0.0549. Is that what you guys are thinking?
That's what I got.
wait, say that
Yeah,
again?
that's what I got.
So you click the right and the left sides of the applet, because that's the
Uh-huh.
most extremes at either end, and it gives you the probability of 0.0549.
That's what I got.
And I don't know why it's not allowing me. Oh, because I didn't put continue. Duh. Yes. Okay.
Yeah,
All
that
right.
makes sense. Kind of like number 3, like when you put in the applet.
Yeah. Yeah, I think after talking through it with everybody, I think that is right, but you know me, I'm not the
And then
final word.
So I
we
guess
just have to round it up, right?
Yeah.
Well, so only to 5.5, right?
Yeah.
Because it's to the
Yeah.
third decimal place. Good catch, hey? So 0.055 is what we're going with?
Yeah.
so here's my question. How do you know when you need to use the square root of n and when not to use the square root of n?
Well, I think for a couple of reasons. One, it says the sample mean. So they're talking about the sample, and in this case, the sample was out of 48 passengers. So it
tells
gave you a mean to a sample and the amount that was in the sample. Does that make sense?
Yeah. So when
Yeah.
we're given n, we need to use n.
The way it
Correct.
says in the textbook says that the sample mean is normal. If you determine that the sample mean is normally distributed, then you can calculate probabilities using that equation.
And it's normal, so.
Yeah.
Okay.
So that's when you use it whenever it's a normal
Right.
distribution.
Or Abby normal, just kidding. I'm really tired. I worked the last 2 nights. Sorry, guys. So I got like 4 hours of sleep today.
Well, thank you for braving it with us.
Braving it with me? What are you talking about? Okay, who's up?
Number
I'll
5.
do it. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means. This cannot be determined by the information given. Which is the smallest? Is it the first one? I don't know if I'm
What does
understanding the
everybody
question.
think?
I got the second one. That's
Me
what I think.
too, because of the fact that usually the standard deviation of sample means is smaller than the
Yeah.
population mean, so that was my rationale for that. Whether that's correct or not, I don't know.
Yeah, I agree.
What do you think, Kayana?
I agree.
That didn't sound very confident, girl. We need
That's what I had. I
conviction.
put the middle one.
All right. All right.
Okay, can you guys explain to me why?
Like I said, just because if you look at the standard deviation, like look up at the top, right? The standard deviation in number 4 was 26.7, right? But the standard deviation of that random sample was less, right? It was
Because you divide it
3.96.
number.
It was 3.936 was the standard deviation of the sample mean, right? So that's why I'm just saying, I don't have like a formula for you. Just from doing all of these, it seems like a trend that the mean of the sample is always a lot more narrow than the mean of the population.
Okay.
Another thing too, if you look at number 6, it kind of gives you the answer to number 5.
Okay.
Which of the following results implies that the spread of X bar decreases as sample size increases?
Right, exactly. Which is?
Law of large numbers, right?
That's what I put as well.
Okay.
Does that make sense to you, Veronica?
Yeah.
Because remember, the law of large number has to do with the accuracy, the smallerness of the standard deviation, and the central limit of theorem has to do with the shape.
Okay.
Yeah, that if you have a large enough sample, it's going to give you an approximate normal. Whereas the law of large numbers says if you use a large sample, you're going to get a more accurate standard deviation to the real population. Am I explaining that right?
Yeah.
Kayana and Hay, am I explaining that right?
Yeah.
Yeah.
Okay.
And like also on the notes it said, like, I think it said something like that.
Okay. All right.
Works for me.
Is it my turn?
Yeah.
Sure.
Yeah.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diana's score? So this is the answer to your question, Kayana. In this case, they didn't say, here's the...
They're just looking at her one, right?
Right,
Yeah.
exactly. So it's the normal one where you subtract, you do 160 minus 150.8 and divide it by the standard deviation. So the Z-score for this, what I got was 1.045.
Yeah, that's what I got.
That's what I got.
Okay, perfect. Okay,
Veronica,
who's up?
that one?
My turn, I think.
Okay.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? I don't know how to do this.
So don't we just stick that Z-score from number 7 on the normal applet and take everything above that?
Oh, yeah.
Isn't that what we do, guys?
That's what I do.
The Z-score was 1.045?
Yes.
Correct.
Yeah.
All right, sorry, I was kind of doing it because I hadn't done that one.
That's okay. So the applet, you stick that in there, and everything above that, what'd you get, Veronica? Since you have it right in front of you, just to double check us.
Hold on.
I got 0.148.
That's what I got too, 0.148.
Yeah.
Yeah.
Kayana, did you get that as well?
Yeah.
Okay. Good. Okay. Hey, I wrote notes on this one because you know how sometimes I do one and then I'm like, how did I figure that out? I got it all plotted out tonight. Okay. Go for it. Whoever's turn it is.
A random sample of 5 students was selected to take the GRE. Their scores were 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? So this is where you use the square root of n formula, right?
Right.
So I did the math, but I didn't label it all, so I'm not sure. But you have to find the mean of those numbers.
Yeah.
Right. Yep, so we added those all together and divided it by 5, right?
Yeah.
Okay.
What did we get for that? The mean?
I got
160.
160 for the sample mean.
Me too.
You guys?
Yeah, I did too.
Okay. So then you plug it into that formula with the sample mean minus the population mean.
Oh no. Okay.
And then you do it, divide that by standard deviation divided by the square root of 5.
What's the? Oh, 5 students, right? That's the.
Right.
Yeah.
Okay, sorry.
That's okay. So
So the z-score I got was 2.338.
Yes, that's what I got.
I got 2.337, but
But you round, it's 2.3377, so you have to round the 7 to 8.
Yeah,
Oh.
because it's 3 decimals place.
okay, I just probably didn't see that the next one was higher. So, okay, so 2.338.
8. Yeah.
Very good. All right, who's up? Because I left this one blank too.
Wait, what did you guys get?
2.338.
2.338?
Yeah.
Oh, isn't it 3.4?
Let's
No,
everybody
I
check.
meant, sorry. No, never mind.
Are you
Wait, I didn't get that.
okay? So the mean of those 5 is 160, right, Veronica?
Yeah.
And then
Yeah.
you subtract the 150.8, and that's the top of your equation, right? So that's 9.2. So that is going to be divided by, find the square root of 5, which is 2.236.
You know what? I figured out what I did wrong.
Okay.
Yeah. Okay. Yeah, I put the wrong numbers in the wrong place. I get it.
All right.
Sorry.
No, that's great. I'm glad.
All right, number 10. What is the probability of the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problems?
So you just put in the z-score that you got for 9, right?
Let's see. What is the probability that these
Yeah.
students have a mean score that is greater than the mean achieved by the students in the previous problem?
So you just put in the z-score.
0.00, actually 0.01.
Yeah,
Can you guys
0.02.
explain to me what your thought process is and how you got that? Because I'm confused. I don't know how to come to
Okay.
that.
So they are looking for the probability that the randomly selected students will have a mean score that is greater than the mean score achieved by the students in the previous problem. So the mean score from number 9 is 160, right?
Right.
And you have to do the z-score for 160 is the mean. So it would be 160 minus 150.8 divided by the standard deviation divided by the square root of 5, which we did for problem 9.
Okay.
And so you put that into the applet,
Okay.
and then they're looking for the score that is greater. So you just have to make sure that the right side is highlighted and not any other side.
And you put in that z-score of 2.338?
2.23.
2.338. And so the probability was the 0.00 .0097.
Yes. And in this problem, it actually says to round to 4 decimals, so we probably want the 0097, which is what makes me think that it's correct.
I didn't even see that.
What?
Yeah, I hadn't even seen that.
Yeah. I looked at that earlier, and I was like, oh, well, that makes sense because there's 4 decimals, and it's such a small number. They probably want to make sure.
Wait, so what was the answer? 0.0.
.0097.
Oh my gosh, Epiphany, I thought it ended at 10. So I didn't do the last 5 questions.
There's 5? Oh.
So anyway,
Yeah.
I'll try and catch up here.
That's okay. These last 5 are pretty simple. I think they're a review.
All right, who's next?
I think it's Kay's turn.
Okay. Kaylin, me? Not Hey? Not Kayanna? Okay.
No,
All right.
So,
Okay. Well, you know what? They always try and mess you up, but they're trying to drill into our head the central limit theorem. So even though it's left skewed distribution, the random sample is 81 students. So therefore, it's going to be approximately normal.
Yeah, that's what I got.
That's what I got.
Okay.
Alright, my turn, I'm guessing.
Mm-hmm.
What is the mean of the distributions of the sample mean for all size 81 that could be drawn from the parent's population?
Oh, geez. Now it's another one of those big, huge formulas again, huh?
the square root of 81 is 9, so it's going to be 0.7 divided by 9 for the bottom.
Okay.
And that's 0.077777777777.
So what is the mean, sample mean? Is it the same as, where's the sample mean?
It's 3.5, isn't it?
Mm-hmm. So, yeah, the sample mean is going to be the
Well, then what's the regular mean?
3.5.
They're
mean
the same?
Yeah, the standard deviations change, but the means stay the same. Because of the law of large numbers.
I'm confused. Because how can you do the formula of the sample mean minus the mean if they're the same number? You're going to get a 0.
Well, it says the sample means it is 81.
No, that's
So
the
I think the answer is just
That's the sample
3.5.
size. The sample size is 81.
Oh, wait a minute.
See what I'm
Find
saying?
the mean. We're not. Wait.
What is the mean of the distribution?
We're trying to find the mean, aren't we?
Yeah, so I think it's just 3.5.
Yeah, the mean is mu.
Yeah.
So the mean overall is 3.5. But
Yeah.
the mean for a sample, a distribution of sample means, is mu. And so
That's correct. Okay.
so it's going
So
to be 3.5.
I guess they were confusing me because they were
They're trying to trick us.
saying, yeah, like round it to 1 if you have 4 decimal places. I'm like, what the crap? Why would we have 4 decimal places? Sorry,
Yeah.
excuse my language. What the crud? I don't know. All right. Okay. Mhm.
So 3.5 for 12. Yes?
Yeah.
Yes.
3.5, right?
Correct.
Okay. I heard her say 2. That's okay. It's probably just my hearing.
Okay, 13, I can do that one. What is the standard deviation of the sampling distribution of the random variable x bar, the mean of the 80... What? Does that
I
make sense?
know. I
What is the
know.
standard deviation of the sampling distribution of the random variable x bar, the mean of the 81 students who are selected? What?
I know. I'm confused as well.
I think I got it. Hold on.
Are you just using the SPS thing to find out?
No.
I don't know. I
Look at
don't
the
know what the standard deviation of the sampling distribution of the random variable X.
So, I think this is where we take the standard deviation and then divide it by the square root of n because we are given a number of students.
Yeah, I think you're right because we have a
Yeah.
standard deviation up here, and then we have the 81. So 0.7 divided by 9, right?
Yes.
Is that what you guys are thinking?
Yeah.
Divided by
I got
9.
0.078.
That is it
That's what
just
I
a
got.
3 or do they want it to 4? 3. Okay.
Yeah.
0.078.
Yeah. That's what I got.
Yes.
0.078. Okay, we were making it too complicated.
Yeah. I think it's just really simple, but we're just thinking too much.
They're trying to blow our minds. Okay. Okay.
Okay, so the next one is, what is the probability that the mean GPA of 81 randomly selected BYU students will be less than 3.3? Don't we have to find the Z-score and then
Mm-hmm.
use the applet?
Mm-hmm.
Yes. I think.
So the Z-score, that's why I'm confused then because we don't have a population mean and a sample mean. Oh, yes, we do. 3.3 minus 3.5. Okay, let me do some math here. Sorry, if you guys have already done it, I'm sorry, just 1 second.
No, you're fine.
Hey, it's okay. I can do it again.
Yeah, double check, so. And then we're divided by, let's see, the standard deviation was. What's the population standard deviation? Was 0.7. 0.7 divided.
We're looking for less than.
Which is 9.
Yeah,
so
less than 3.3.
clear. And so 0.7 divided by 9 entered is 0.7.
I got minus 2.571.
7.
Yep.
Just 1
Yeah?
second. I'm not there yet. Sorry.
Yeah. Yeah.
What did you guys get for the Z-score?
I got minus 2.571.
I got minus 2.564.
Oh.
Did
Cause
you-
like 0.33?
Wasn't it negative 0.2 divided by 0.078?
Yeah, I just did all the 7 because I do it all together in the calculator.
So your what you did is you didn't take it. Since you rounded, you just used the rounded number. It's not
Right.
going to be as accurate.
Okay.
So what I did is I
so-
took everything. I didn't take the
Well,
short.
sometimes
That's probably
it's
what it
so
was.
confusing in this thing because he told us to not round, but then some of the answers don't come out right unless you do round. So it's kind of confusing. I wish they would be consistent, right?
I think when we're looking for the answers, he doesn't want us to round until we have come to the end. So like
Yeah.
13, that's the end for that problem.
Right, but I'm just saying
14.
in my experience, even sometimes when you don't round before you get to the end, you get a different answer, but it's whatever. So, let's see. This goes, let me just get to where you guys are. Sorry, just 1 second.
You're fine.
1, 2, 3, 4, 5. So how many sevens? 1, 2, 3, 4, 5, 6, 7, 8.
Oh, 8?
8. 0, 1,
I'm sure
2,
it keeps
3,
going
4,
after
5,
the
6,
calculator,
7,
too.
8, 8. Okay. So then let me do 0.3 minus
No, it's seven. It's
3.5
7, 7.
divided by 0.01234567. You think there's only 7 sevens? I counted 8.
Well, I think it depends on your calculator. It's fine.
Okay. So then, did you guys get 2.571?
Yeah.
Yeah.
Mhm.
Okay. So then we plug that into the applet.
Yes.
Yeah.
And then we want, it says less than 3.
2.571. And then we're supposed to take what now? The probability of the mean that is less than?
Yeah.
So is that
left?
the left of
The negative.
the negative? Okay. Why the left of the, oh, because that's what our, okay.
Yeah.
So then did you get a 0.0051? So
Mhm.
0005?
5, yeah.
Okay, sorry. Thank you for letting me work through that.
That's fine. And then the last one is the same thing, but it's greater, so it's everything to the right of the
Oh.
negative.
Okay.
Well, that was nice of them to be easy on us.
Right?
So that is also though 0.005, right?
No, it's greater
No.
than, not less than.
Oh, I'm sorry. Greater than. I forgot that. So 0.995.
Mm-hmm.
Yeah,
Okay.
Yeah.
oh my god.
Okay. Alrighty. Whew. Who's going to submit first?
I don't know. I'm scared this week.
I'm gonna submit right now.
We're good. I
You
already did it.
Oh, we're good?
Yeah, we're
How'd
good.
we do? Okay.
Good.
Awesome. You're so brave.